निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Welcome back. In this session, we will be continuing with the exercise 12.3, the solution for the exercise 12.3 for chapter 12, areas related to circle. This is the third session of exercise 12.3. Moving on to the question number 10. The area of an equilateral triangle ABC is 17320.5 cm square. This is given in the question. With each vertex of the triangle, as a center, a circle is drawn. We are drawing, taking each vertex as center, and the radius to be the half of the side of the equilateral triangle AB. Three circles are drawn, taking the length to the half of the side of the triangle. We need to find the area of the shaded region, and this is the shaded region that we are talking about. We need to find the area of this shaded region. In order to find the area of this shaded region, what will we have to do? We will have to subtract these three sectors from the whole area of the triangle. Area of the triangle is given to us 173,205.5 centimeters square. In order to find the area of the sector, we know that the area of the sector, the formula is theta by 360 into pi r square. Theta, we know, since it's an equilateral triangle, all the angles are 60 degrees. So the central angle for all the three sectors is 60 degrees. We need the radius for this radius. In order to know the radius, we should know first the side of an equilateral triangle. As in our question, it has been said that the radius is equal to half the length of the side of the triangle. Half the length of the side. What is the length of the side? What is the length of the side of the triangle? That equilateral triangle. So we will have to first calculate that length. So let us move on how to find the length of or the side of the equilateral triangle. That can be found out by using the area of the equilateral triangle. And we know the area of the equilateral triangle is root 3 by 4 side square. So let us move on with this. Area of equilateral triangle ABC. This is given to you as 17320.5 centimeter square. And area of the equilateral triangle is given by the formula root 3 by 4 side square is equals to 17320.5 centimeter square. The value of root 3 is also, we are given the question to use the value of root 3 as 1.73205. So we will be using that. So 1.73205 divided by 4, and in place of side, suppose we write AB square, and that is equals to 17320.5 centimeter square. So AB square is equals to 17320.5 into 4 by 1.7320. Solving the right hand side, if you remove the decimal place, we have 5 decimal places, you can multiply 10 to the power 5 in the numerator and remove the decimal place and 1 here. In short, if you solve this one, you will get as 440,000. So AB will be the root of 40,000, that is 200 centimeters. So we have got the side of the equilateral triangle to be 200 centimeter. That means now we can get the radius of the sectors as half of the side, because in the question it was given that the radius is the half of the side of the equilateral triangle. So for the sectors, for each sectors, for all the three sectors, the radius will be 100 centimeters. So radius for all sectors, we can write somewhere here. Radius for sectors. For all sectors, you can write if you want. That is equal to 100 centimeters. Now we'll be moving on to find the area of the shaded region. So area of the shaded region is given 1. We have discussed earlier also, as I have explained, that area of shaded region is area of the equilateral triangle ABC minus 3 into area of each sector. That is, we are taking the area of the triangle minus the unshaded region and we will be getting the shaded region. So area of triangle ABC, that is given to us in questions. We should not calculate once again. So this is 17320.5 minus 3 times of area of sector is theta by 360 into pi r square. So this is 17320.5 minus 3 times theta is 60 degree for each. So this is 60 by 360 into the value of pi we have to take is 3.14 as given in the question. 3.14 into the radius that we have got for each sector is 100. So this will be 100 into 100. Let's do this, we can write it straight. 100 into 100. Now we'll solve it. This is 17320.5. Let us cancel this one. 6 and 3 2s and this is 2 1.57, so this is minus 15700 centimeter square. Centimeter everywhere, yeah, it's a centimeter square. Now we'll subtract 17320.5 minus 15700.0. This is 0.52061. 1620.5 centimeter square. 1620.5 centimeter square. So this is the area of the shaded region that is required in our question. And what we have done, we have first of all found out the side of the equilateral triangle. The side of the equilateral triangle was 200 centimeters. Half the side of the equilateral triangle was the radius for all the sectors, that is 100 centimeters. And then we found out the area of the shaded region by subtracting all the three sectors from the area of the triangle, and we obtained on calculating that the area of the shaded region is 1620.5 centimeter square. Question number 12. In the figure, that is the figure is given to us. OACB is a quadrant of a circle with center O. OACB is the quadrant of a circle with center O. We need to find the area of the quadrant OACB and the area of the shaded region when OD equals to 2 cm is given to us. Moreover, we are given with the radius of the circle. Let us move on to the question once again as a whole. In the given figure, OACB is the quadrant of a circle with center O and radius 3.5 centimeters. So radius is 3.5 centimeters. So we can say if O is the center of the circle and OACB is the quadrant of the circle, then OB is the radius of that circle, which is given to us as 3.5 centimeters. We are also given if OD equals to 2 centimeter. OD equals to 2 centimeter. From here to here is only 2 centimeter. We need to find the area of the quadrant and the area of the shaded region. Quadrant, again that word came that we had discussed in our previous sessions. Quadrant means the angle is 90 degree. It is the 1/4 part of the circle. It is 1/4 part of the circle where the angle is 90 degree. So we can consider this angle to be 90 degree because this is the quadrant, this is the 1/4 part of the circle. So the angle at the center O will be 90 So we have to first calculate the area of the quadrant OACD, and we know that quadrant means it's a type of sector only with angle to be 90 degree. So let us find the area of the quadrant or area of the sector with central angle 90 degree. So area, this is bit 1, the solution for bit 1 we are doing. So area of quadrant OACB, this is given by theta by 360 into pi r square. This is the area for finding, this is the formula for finding the area of the sector here. Quadrant means the theta is 90 degree. So 90 by 360, substituting the value of pi, say 22 by 7, and radius here is 3.5. You can write this one as 35 by 10 into 35 by 10. The whole on simplification will give me the area of the quadrant OACB. Let us simplify. This is 90, 4 is 7, 5 is and 5, 2 is we have anything else to cancel? Yes. 5 2s and 5 7s. We don't have anything else, I think, for simplification. So this is 22 into 7 divided by 4 into 2 into 2. This is 154 bar. Where is 22? We have more for simplification we haven't seen. We can cancel this one also, because let us remove this part. It can be simplified more. This 2 can cancel here, 11. So this is 11 into 7 by 4 into 2. So this is 77 by 8 centimeter square. So this is the area of the quadrant that is required, O, A, C and B. Moving on to the picture part, we need to find the area of the shaded region. We need to find the area of this shaded region. We can see that area of the shaded region can be calculated by subtracting the area of this triangle from the area of the quadrant. So area of shaded region, we can move on with that. Area of shaded region that is to be calculated is given by area of quadrant OACB minus area of triangle BOD. Area of the quadrant we have calculated, so no need to calculate once again. This is 77 by 8 minus area of the triangle is always given by the formula half into base into height. So this is half. Here the base is OB and the height is OD. So this is 77 by 8 minus half into OB is 3.5, calculated as 35 by 10, and OD is 2. So we can write here 2. On simplification, this cancels 2. 77 by 8 minus 35 by 10. You can directly write 3.5. Let us calculate this also so that we can get a particular answer for that. Let's divide 77 by 8. 9s are 72 and 5 and decimal point 50. So this is 6 48, 2, 20 and 2s are 60, 4, 0, 40. So 5. So this is 9.625. 9.625. We could have mentioned here also, here calculating. So let's simplify here also. We could have mentioned here 9.625 centimeter square if we want. Then moving on here, this is minus 3.5. So this calculated as 6.125 centimeter square. So this is the area of the shaded region that is required in our question that we have obtained by subtracting the area of the triangle BOD from the area of the whole quadrant OACB, we had calculated the area of the quadrant as 77 by 8 centimeter square. So we have substituted here, and the area of the triangle is half into base into height. Substituting all the values and solving it, we finally get the area of the triangle, area of the shaded region to be 6.125 centimeter square. Question number 13. The 12th one is again left out for you for practice purpose. 12th one I think we have done. In the given figure, a square OABC is inscribed in a quadrant. OABC, this is a square, that means all the sides are same. So it is a square that is inscribed in a quadrant OPBQ. In the quadrant OPBQ, the square has been made inside the quadrant. If OA equals to 20 centimeters, we are given OA is 20 centimeters. That means we are given the side of the square to be 20 centimeters, and we need to find the area of the shaded region. In order to find the area of the shaded region, observing very minutely, we can say that if the unshaded region, that is the square part, if we subtract this unshaded region from the whole quadrant, we get the shaded region. That means area of the quadrant minus area of the square will give me the area of the shaded region. So in order to find the area of the quadrant means the angle is 90 degrees. In order to find the area of the quadrant, we need the radius for that quadrant. Here the radius for the quadrant is OP, or you can say OQ, which is not given to us. That means first of all, we need to find a radius for the quadrant. So let us join OB. This is also the radius of the quadrant. We can find the value of OB by considering the triangle OAB and applying the Pythagoras theorem, because OA is 20 centimeter, then AB is also 20 centimeter, because OABC is a square. So we can get OB from the triangle OAB applying Pythagoras theorem. So let us first move on to find the radius of the sector from the triangle as OB. So in triangle OAB, OB square is equal to OA square plus AB square. So this is hypotenuse square is equal to the sum of the squares of the other two sides in a triangle. That's what is Pythagoras theorem. So OB square is equal to 20 square plus 20 square. This is, you can say, if you take out 20 square common, this is 1 plus 1, 2. So this is 20 square into 2. And if you find OB, this is 20, the root under 2, that is the square root of 20 square into 2, that will be 20 root 2. So we got OB to be 20 root 2 centimeters. This OB is the radius for the quadrant. So we can mention that OB is equal to 20 root 2 is the radius for the quadrant. And now, on getting the radius, now we can move on to find the area of the shaded region. And how will we finding out? We'll be writing area of shaded region is equals to area of the quadrant. What is the name of the quadrant? OPBQ. OPBQ minus area of the square O, A, B and C. This is the name of the square OABC. So area of the quadrant minus area of the square. That means the area of the quadrant minus area of the unshaded part will give me the area of the shaded part. So area of the quadrant is given by theta by 360 into pi r square. This is the formula for finding the area of the quadrant, where theta will be equals to 90 degree minus area of the square is always sine square, that we know. So let us substitute all the values. 90 by 360 into pi. We are asked to take pi as 3.14. So we'll be taking 3.14 into radius of the quadrant that we have calculated is 20 root 2. So this is 20 root 2 whole square. This will be my area of the quadrant minus area of the square is side square. And the side was given to us as 20. So this will be 20 square. Simplifying and solving, we will get the area of the shaded region. Let us move on for simplification. This is 94. So this is 3.14 by 4 into 20 into 20 into root 2 into root 2 is 2 minus 400. Then this cancels. 2s are and 2 cancel. So this is 3.14 into 2. 6.28 into 100, 628 minus 400, which is 228 centimeter square. That is the area of the shaded region will be 228 centimeter square, which is obtained by subtracting the area of the unshaded region from the area of the whole quadrant, which gave me the area of the shaded region. Question number 15. In the given figure, the figure is given to us. ABC is a quadrant. ABC is a quadrant. So from here till here, this is a quadrant. And semicircle is drawn with BC as diameter. So this is the triangle that is formed inside the sector of the quadrant, and taking BC as diameter, a semicircle is drawn. We need to find the area of the shaded region that is lying between this and that is the region lying between the semicircle and the curvilinear part of the sector. Now, if you see the whole figure, if you need to find the area of the whole figure, then what you have to do? You have to take the area of the triangle and you have to take the area of the semicircle. So if you add the area of the triangle with the area of the semicircle, you get the area of the whole figure when you are neglecting what is the shaded region. But when you are taking into consideration the shaded region, after taking the area of the whole region, if you see, if you take area of triangle plus area of semicircle, you get the area of the whole, and if you subtract the area of the quadrant from the whole, you get the area of the shaded region. It is very clear. But in order to find the area of the triangle, we know that is half into base into height. So this is a quadrant, and we are given with the radius that is 14 centimeters. So we can have written here 14 centimeter, and this is also 14 centimeter. While moving on to finding the area of the semicircle, first we will have to find the diameter of the semicircle so that we can get radius from it, as this semicircle was drawn taking BC as diameter. So the very first thing that we will have to find out is, let us find out the diameter of the semicircle from the triangle ABC. So in triangle ABC, BC square is equals to AB square plus AC square. That is by applying Pythagoras theorem. That is the sum of the squares of the two sides is equals to the square of its longest side, that is hypotenuse. Let us find BC. So AB square was 14, so this is 14 square plus 14 square, and if you take out 14 square common, this is 1 plus 1, this is 14 square into 2. For finding BC, if you take the square root of this, you get as 14 root 2. So this is the diameter for the semicircle. That BC is the diameter of the semicircle. So the radius will be half of this, that is BC by 2. So radius for semicircle is half of BC. So radius of semicircle is half of BC, that is half into 14 root 2, and so this is 7 root 2 centimeter is the radius for the semicircle. Now let us move on to find the area of the shaded region. That as we have discussed while we were starting, that we need to find the total area of the figure and then we will subtract the sector from it. In order to find the total area of the figure, we have to add the area of the triangle plus area of the semicircle. And by subtracting the area of the quadrant, we get the area of the shaded region. So, area of shaded region is given by area of triangle ABC plus area of semicircle with diameter BC minus area of quadrant AEX. So area of the triangle is half into base into height. This is half into base into height plus area of semicircle is half pi r square. Here r is the radius of the semicircle minus area of the quadrant is theta by 360 into pi, say r square, capital R square, where capital R is 14 centimeters. Substituting the values and solving, we would be getting the area of the shaded region. So half into base is 14 into 14. This is area of triangle plus half into pi. We can take 22 by 7, and radius for the semicircle was 7 root 2 that we had calculated. So this is into 7 root 2 into 7 root 2 minus area of the quadrant. Theta is 90 degree. So 90 upon 360 into 22 by 7, and radius for the quadrant is 14 centimeters. So this is 14 into 14. So let us simplify it. 7. This is 84 plus this 7 and 7 cancels. Root 2 into root 2 is 2 and 2 cancels. So these two root 2 was 22 into 7 is plus 154 minus. Let us simplify this one. 94 is 7, 2 is 2, 2 is and 2 7. Again 22 into 7 is 154. So this cancels, we get finally as 84 centimeter square. So the area of the shaded region that we were looking for is 84 centimeter square. Let me recall once again. First of all, we have found the area of the whole figure by adding the area of the triangle plus area of semicircle, and then we subtracted the area of the quadrant from the whole area, getting the area of the shaded region as 84 centimeters. Question number 16, the very last question of this exercise. Calculate the area of the shaded region as shown in the figure, which is common between the two quadrants of the circle of radius 8 cm. So this is one quadrant, and second quadrant is from this side, and the area enclosed between the two quadrants, we need to find that E. Now, while observing, it seems to be very difficult. Oh, it's a common area, but it is the most easiest way to solve it. Just join the two opposite ends this way. First, make the square as A, B, C, D, and join BD. Now, if you observe, leave this part. As soon as you join BD, the total shaded region is divided into two equal parts. One, say part 1 and part 2. These are the two equal parts into which this line BD will divide the shaded region. Now, if you consider any one of the quadrant, suppose we consider the quadrant ABD. In ABD, if we want to calculate the shaded region 1, only the shaded region 1, what we have to do? We have to subtract, let me show you, it's some another figure. Suppose we are considering only this quadrant, A, B, and B, and we need to find this same part 1. How can we calculate? This is the simplest area of the quadrant minus area of triangle will give me the area of the shaded region part 1. Similarly, moving for the second part. Suppose this is my square. If you want to move this way, and this will be your part 2 for this quadrant. Again, you can get the area of part 2 same method. Area of the quadrant minus area of the triangle will give you the area of the shaded part 2. And if you add part 1 and part 2, you get the area of the total region, the shaded region that is common to both the quadrants. So we need to find only one, and then we will be subtracting, multiplying it with 2 because both are same. So we will have to work out for only one shaded region, part 1, and multiplying it by 2 will get the area of the whole shaded region. So let us consider this figure out apart from that. So in order to find the area of part 1, area of part 1. This will be equal to area of quadrant ABD minus area of triangle ABE. The area of the quadrant is given by theta by 360 into pi r square, where theta is 90 degree because it's a quadrant, and radius is 8 centimeter that is given in the question, minus area of the triangle ABD. It's a right angle triangle, so half into base into height, or you can say half into base into height from wherever you take. So this is half into base is AB and into height is values of theta, that is equals to 90 degree for the quadrant. Radius is 8 centimeter that is given in the question. For the triangle ABD, the base AB is 8 centimeter, it's given there, and our height AD is also given. Just we will have to substitute, and we will have to obtain the area for part 1. So let us substitute the value. This is 90 by 360 into the value of pi is 22 by 7, and radius is 8 square. Minus, this is half into base is 8, and height is also 8. Solving and simplifying will get the area of part 1, the shaded region, the area of part 1. So let us simplify it. This is 90, 4s are 2, 11s are and 2, and here this is 8 square. So we could have written this right once again, 11 into 8 into 8 by 2 into 7 minus 2 4s are, this is 22. So again this 2 can be cancelled, 4, so 88 into 4 by 7 minus 32. Let us calculate this one. 8, 32, 2, 3, 352 by 7 minus 14, 4, carry over 1, 22 by 7, this is 128 by 7 centimeter square. So we have got the area of part 1 as 128 by 7 centimeter square. Now we, as I have told you earlier also, that area of part 1 will be same as the area of part 2. So we will be just writing, and we did not again calculate. So area of part 2 is also equals to 128 by 7 centimeter square. As we get the area of part 1 and part 2 both as 128 by 7 centimeter square, now we can find the total area of the shaded region by adding area of part 1 and area of part 2. So area of shaded region, finally the area of shaded region is area of part 1 plus area of part 2. So this is 128 by 7 plus 128 by 7. This is 256 by 7 centimeter square. So we have got finally the area of shaded region as 256 by 7 centimeter square. Now what we have done is, once again revise it or recall it, we have taken or considered only one quadrant, and we have taken only one part. Out of the two shaded parts we consider only one shaded part, and we found the area of that shaded part taking ABD as the quadrant as area of quadrant minus area of triangle. We have substituted the values for the things and we obtained the area of part 1 to be 128 by 7 centimeters square. Area of part 1 and area of part 2 will be same because both the quadrants have the central angle as 90 degree. Moreover, both the quadrants are of same radius 8 centimeter. Even the triangle area of triangle ABD and area of triangle BCD is also same. So we consider the area of part 2 to be same as the area of part 1, that is 128 centimeter square. And finally we moved on to our area of shaded region by adding area of part 1 and area of part 2, which we got as 256 by 7 centimeter square.